Okay, hello there. I'm going to do this again, giving it a go with doing these lives for a merit question a day. Now, yesterday I just did one of them because I was just trying out this live thing, but I'm going to try and see if I can keep up with as many as possible of doing one of each type. So a complex number one, a differentiation, and an integration one. I'll do them as frequently as I can fit into my day. Now, the reason that I pick out merit question, if you are working towards an achieved and not quite at merit, there's always parts at the beginning of a merit question that can help you get achieved, and sometimes they're a little bit easier than the achieved questions themselves. And if you're working towards excellence, then you need the merit skills to be able to build up towards excellence as well. So merit is a nice middle ground for everybody to practice a little bit of something that's useful. Okay, so I've got a differentiation question up. We'll have a go at doing that. So we've got the x values. We want to find the x values of any points of inflection on the graph of the function y equals e to the 6 minus x squared. Okay, let's just get rid of the webcam for a second. Okay, so I'm just going to sort my stuff out so I can see there. All right, so we have the situation is where we've got points of inflection. Now, for points of inflection, we need the second derivative, so we're going to need to work through the first derivative first. Now, we're integrating e. With e to the x, it's on your formula sheet, just integrates to e to the x. So if there's something inside of the power, then we need to use chain rule. So we differentiate the inside of it. So it'll be e6 minus x squared times by negative 2x, the derivative of the inside. So I'll just pop that at the front to make it a little more concise. So that's minus 2x e to the 6 minus x squared. Okay, now we need to do the second derivative. And that means we need the product rule. So we'll differentiate the first thing, multiply it by the second thing. And when I say product rule, it's because we've got a piece here that's being multiplied by a piece here. So that's why I'm using the product rule. So I differentiated the first thing, times it by the second thing, and then add on the derivative. Well, the original thing doesn't get changed, and then we differentiate the second thing. So the e to the 6 minus x squared. Well, that's what we did for our first step. So we just do that again, like this. Okay, so tidy that up a little bit just to make it easier to see what we're doing. Ooh, and we've got minus 2x times minus 2x, so that is plus 4x squared e to the 6 minus x squared. Okay, now back to the point of this. We are looking for points of inflection. Now that happens when the second derivative is equal to 0. That's something that you will need to memorize. Okay, so actually I don't need an equals there. I'm going to factorize out what we can here. So if I take out 2 and then an e to the 6 minus x squared, then from the first term we've got a minus 1, and from the second term we've got a plus 2x squared, and that equals 0. Now this portion here can't be equal to 0 because e to the power of something can't be 0. If you tried to solve that, you'd get a math error on your calculator. If we've got two things being multiplied together, like we have here, giving us an answer of 0, one of those things must be 0. Now, since this e part can't be 0, then the bracket must be 0. So that bit there has to be 0. Okay, so that means that 2x squared is equal to 1. So x squared is equal to a half. So x is plus or minus 1 over root 2. Okay, now for that one, you can get the achieved mark within there, and I'll just check where that is before I pop that on there. Okay, so the achieved point was for doing the very first step here. Just that one there, that one got you an achieved. And then getting to the end here was where the merit was, but they actually specified in the mark scheme that you didn't need the plus or minus, so if you only put plus, a positive answer there as like 1 over root 2, you still would have got the mark. Okay, all right, let me just load up the integration question. Okay, let's move on to here. Okay. We have an object that is moving in a straight line. We've got the velocity of that object. So straight away, this tells me we are talking about kinematics. So we're thinking between speed and distance at the moment. We've got this formula here for the velocity or speed, and that's from the time it started moving. We're told that it's measured in meters per second. And we want to find out how far, so that's displacement, in the 4th second. Okay, so to get from velocity to displacement, so displacement we call s of t, that's the integral of the velocity. So we need to integrate the function that we've got there. If we integrate 6, we get 6t. And 5 over t plus 1, something that is over x, or in this case over t, that integrates to natural log. That one's on your formula sheet. So bring the 5 out to the front, and then you're only thinking about the 1 over t plus 1, makes it a little bit easier. So that is just the natural log of t plus 1. Now, if we had something inside of that function that was more than just a simple t, we would have to differentiate and do reverse chain rule on it. In this case, if we differentiate t, we just get 1, so that's not going to change anything if we needed to times or divide by the 1, right? So we have this integral here. We are integrating between, we're wanting to work out how far it's travelled in the 4th second. Now that means that we are integrating between the 3rd and the 4th to be able to get that distance that it travelled in the 4th second. Now the 4th second, that one often catches people out as to when do you stop and start for the 4th. Is it between 3 and 4, or is it between 4 and 5? I always try to get students to think back to what would you call the 1st second. The 1st second would be in the time space between when we started and when we hit the time being 1 second being passed. So if that's the 1st second, think about it again. So the 2nd second would be here, the 3rd second, and then the 4th second. So you can see now the 4th second is between second, when the time is 3 seconds and when the time is 4. Okay, let's just move that out the way. Okay, so now we can integrate between 4 and 3. So we're popping that into our integral and making it a definite integral. And put 4 and 3 in. So we're going to do 6 times 4 minus 5 log of 4 plus 1, take away 6 times 3 minus 5 log of 3 plus 1. Okay, I'm going to head over to the calculator now. That's not going to simplify into anything particularly helpful to leave it in logs. So let's pop that in. So we go 24 minus 5 log 5, take away 18 minus 5 log 4. Oh, I must have typed something in wrong. Here we go. I think it's that one. There we are. And that is 4.88. Going back to the question, we can see that our distance measurement is up here, so it's 4.88 meters. Now, in terms of where the marks were assigned for that one, we have a achieve point for doing the integration correctly. So if you can get to this point here, then that is where your achieved is sitting. And then getting to the end obviously gets you your merit. Okay, so that brings us to the end of those two questions. Sorry, just one moment. There we go. Pop my webcam back on. So there's the two questions that will help you out with. Let me move that over the side just for anyone that's still wanting to take a look at that. That's today's two questions that finishes off the first set of these merit a day questions. Next time around, I will do all three in one. So we'll do a complex, we'll do a differentiation, we'll do an integration in the one live session. So you've got a practice of all three types to help you getting ready for these externals coming up. Hopefully I will